like I said today, guys, we are preparing, first of all, a flight from Munich to Geneva. And I'll be explaining a little bit about the flight management guidance system, the FCU, MCDU, and tell you some interesting facts about that. I'm sure there's a couple of things, you'll be able to learn. And so the two main functions of the flight management guidance system is, for one, the navigation, flight planning. That's all the pages you have in here. The performance. Then you have the auto tuning of the nav aids. And so this is the navigational part. And then you have so-called flight guidance part. So, like it says, flight guidance has to do with nav display, with the horizontal situation indication, or the primary flight display, with all the modes being displayed here, and of course the auto thrust system, which is or the pilot interacts also through the thrust levers. So the whole system, the whole FMGC, or I should say FMGS system, consists of two flight management and guidance computers, which you can't see. You can only see that they're actually working and displaying the signals or the values that they're calculating. Then you have two MCDUs, multi-control and display units, or multi-purpose control and display units, two of them. Also, you have a flight control unit up here. That's what you would call the autopilot panel. Airbus calls that the flight control unit. And then you have two flight augmentation computers, FAC they're called. And there's two push buttons here, FAC1 and FAC2. And they produce, for example, the characteristic speeds on the speed band. They will do the yaw dampening. So they are interacting with the flight guidance system or the flight control system. Also a very important part. So the pilot can either do long-term inputs, manipulations through the MCDU, for example, by putting in the flight plan, which we'll do in a second. Flight planning, putting in performance data, and the weights and so on. So the MCDU will put that data towards the computer, and the computer, the flight management guidance computer, will then manage the climb, the descent, the cruise flight, the approach, and so on. All different flight phases are optimized by the use and the interaction through the MCDU. For short-term interactions, you would use the flight control unit. All right, so let's get into the programming. And here, for example, I'm using the so-called diffrip to help me program the MCDU. And so to make sure, mnemonic Airbus, thank you very much. So that helps me to make sure I don't miss any inputs. So the first thing that we're going to have to do is press D, diffrip, D for data. Now here, we would look for the aircraft status and make sure that our database is still valid. Now that's what pilots in real life do also. When they power up the aircraft, they make sure that maintenance has inserted the correct nav database. Then we get to the initialization page, init page. And here we are already. Yes, exactly, Airbus fan. If you have a secondary flight plan page, which isn't implemented yet, then you have diff rips, and the last part would be to copy the actual flight plan and make a copy of it. All right, so we are going from Munich to Geneva. Oh, that's the routing that I've taken from from the Eiflersoft EFB. That's no good. Okay, so we are Edelweiss. Edelweiss. Airbus, how come you had the AirRack 17? No, Airbus fan. I'm pretty sure that it also installed into the P3D. Right, cost index 22 cruising level. According to the flight plan, we have cruising level. Where is it? Up here, 360. Zero fuel weight is 58.6. And the CG will get... So you go to payload, and you can type in the zero fuel weight yourself. So I can put in, for example, 58 now. And you'll see the CG, the zero fuel weight CG change. Also, of course, takeoff and weight and takeoff CG. So that's how you would get the CG. And so I inserted 58.6. That's what we've planned on our flight plan. And so it gets 25.8 for the zero fuel. All right, so let me get to the third letter, which is the F. So now we get to the flight plan itself. And so for the departure, we are going to take off runway 26 left. First waypoint is Mercy. So we are going Mercy for Sierra departure. Scroll down all the way to the last waypoint, which is, of course, Mercy. And then you select Airways, you get to this page, and you'll enter the Airways page, which is Yankee, that is Yankee 110. So Yankee 110. Now you don't have to put in the next waypoint, you just have to put in the next airway, Yankee 100. The FMS will look for the fix, the connecting fix. Hi Lucian, which shader do you use? Oh, ask me something different, I don't know. So we have Yankee 100. Next point is Zulu 69. So just put Zulu 69 in here. And transiting the connecting point, that is correct. Especially, yeah, this trick is very helpful if you have long routes. That will save you lots of time. Right, so we were next waypoint then, or airway is Uniform November 869. 869. Olben is the point, and so the last waypoint is Benot. We're going to have to fill that in ourselves, because that is the point at which the arrival route will start. So the arrival route in Geneva, let me just see, why doesn't it jump to the arrival route? Oh, because it's got the aircraft selected here. Hang on. So this is the routing, and it takes us to Benot. Now, from Benot, we are expecting the Benot 1 Papa arrival, which will take us on around the airport. It's because 05 is in use, around the south of the airport. And then we will kind of circle around and approach runway 05. Yeah, so that's the routing, and we said we wanted all the way, and a quick way to get to the departure, to the arrival airport is just press airport. And that way you'll get to the departure airport, and you can quickly scroll down to Benot. Well, actually, from Geneva, we're going to have to do the arrival routing. So we select the runway first, and then go with the Benot 1 Papa arrival. insert that, and we're gonna scroll down, or scroll up I should say, and make sure that the routing is closed. It has no discontinuities in there. If it has discontinuities, then of course the FMS again can't calculate certain waypoints and certain routings, and it'll make an estimation, but this estimation could be wrong. So here we have one discontinuity, and that is because it's missing one point here. Oh, actually I forgot arrival ILS 05. Then you get to the B01 Papa and make sure you press the approach via. And it has no via. Okay, so that's no problem. We have to calculate that point in ourselves. So from Golf 502. It would usually mean manual straight ahead on that last track here, radar vectors, but we are just close to routing. So it's another point in this, which we'll fill in. We're going to clear out the manual and then just close the routing. So this way we've closed and we're flying from Golf 502 to Indus. DR, radios, radio setup. And so for Munich, we have the departure route Mersey 4 Sierra. So that's what I've inserted here. Unfortunately, it doesn't give you any text regarding the departure route. But you can see that we're going to climb to Delta Mike 053. That is here. Yeah, over Mike Sierra Echo, that's correct. With maximum 220 knots, that's also correctly inserted here. 262 continue, and then Delta Mike 053. 7,000 or above, which is okay because the aircraft will be at 138 already, so that's no problem. And indicated speed 250, it says. That's also correct. So in the departure route, you have to make sure that the coding in the FMS coincides with the chart. And so the chart, that what you have available for you and is current, that is master, unless it says something else in the NOTAMs, notice to airmen, which you also have to check. But if there's no change in NOTAMs, then you have to make sure these restrictions are actually correctly programmed in the FMS. You could use the conventional beacons and VORs. So we'll select Mike Sierra Echo, which is 385. So that's one of the things. Oh, sorry, I have to put in Mike Sierra Echo, not 385. Now I know that Munich, for some reason, has that in it, but Munich VOR. No, we're going to use Maisach. We're going to use Mike Alpha Hotel. All right. I know Munich is making problems. It also has it doesn't have Delta Mike November, Munich North, and so on. But anyhow. Just, it's not always the first officer that enters the routing. There are some companies which say the pilot flying enters the routing into the MCDU. Now the climb, cruise, and descent winds usually in real life would be uploaded via the ACAR system. So you would have in here a prompt on the init page saying wind request. And that way you can upload the wind data, which is very nice and comfortable. For us in the FSLabs, since this secondary flight plan isn't activated, also the wind data isn't updated yet. You can access the wind data through the MCDU, however, it doesn't work yet. So what we'll have to do is program an average wind component. And for that, we would look into the operational flight plan. And it's an interesting thing now. The average wind component is situated pretty much on the top of the flight plan. So here you have headwind 12. So I'm going to put H012, and they fixed it. They've corrected the, because on the previous version, when you put in headwind 12, it will throw it out as tailwind. So yeah, that's where you would put in the average wind component. There's nothing else you can do at the moment with the wind. Right, so now comes the init B page. Now we get the load sheet, and we'll just say that load sheet, the final figures are the same as planned by the flight plan, so no changes, no last minute change. And then we get to the performance. Now, of course, we are going to use TopCat. Since we have it, we'll use that. And here it is. Gonna select the Airbus. Now the wind, now I have made my own weather today because I tried to make something interesting. So we're just gonna read the wind and etc. from here, from this weather. Don't know if you guys can see that properly. So Munich has 230 at 11. Also with the wind, some airlines, they would say if you have headwind, you just put calm and just have a little bit of buffer regarding the wind. But let's just put it in correctly here. Temperature is at 9 degrees and the QNH is at 1030. Runway condition is dry, no precipitation. And okay, so that only works with FSX. So we said that the takeoff weight is 64 tons. So make sure you don't put the zero fuel weight in there. You make sure you put the takeoff weight. So 64 tons. Yeah, exactly. That's what you mean, Konstantin, right? That's where you would put in the wind. So optimum flaps, normal takeoff, config air conditioning off. Yep, we'll do that today. 9 degrees, not too warm, so the passengers won't be too unhappy. Make sure you put in the right airport. 26 left is correct. Engine out procedure, 10 miles, Munich south, then left turn back to Munich VOR. So we can actually put this in the second VOR, just in case we need to return due to an engine failure. All right, so let's compute. So Munich has a 4 kilometer, or a 3.2 kilometer, I can't, but it's a long runway anyhow. It's a long runway, so we'll have lots of stop margin, meaning that by the time we reach engine out case 50 feet or stop case stopped on the runway, we still have a lot of margin available. So I'm gonna flex all the way down to 65, meaning less stress for the engines and less fuel flow, less noise. So lots of reasons, good reasons to reduce it all the way to 65. So we put in flex temperature 65. When would you use the engine anti-ice? Okay, important thing to do is have a look at the weather. So 9 degrees on the ground is, well, pretty warm. So during takeoff, we have no precipitation. We won't need anti-ice. Now, you could argue if you have an engine failure, you would have to make sure you reach the acceleration altitude. And if you need anti-ice until then, you would have to put that into calculations. So today, there could be a chance, since it's only scattered 1000, that we're going to enter clouds in the climb and temperatures below 10 degrees. And so we would have to use engine anti-ice. That's why we selected engine anti-ice, and that way we're on the safe side. Because engine anti-ice takes bleed air away from the engines for the anti-icing, meaning less thrust. The minimum margin, well, sometimes you have to accept 0. If you have so much cargo and so on, you have to be aware of the fact that during dry conditions, the reversers aren't actually taken into calculation. So when you have reverse thrust also available, it means you have even more buffer. So you can accept all the way down to 0 margin. I know there's people that some pilots will accept no less than 300 meters margin and so on. And so, yeah. But for me today, like I said, no problem. You can flex all the way up to 65. Why do I turn off air conditioning? Because air conditioning takes away bleed air from the engines, and meaning the engines will have to, in order to produce the thrust for takeoff, will have to use more fuel and higher RPM. And so whenever you are able to reduce the load, i.e. the bleed extraction, it's a good thing to do so. All right, so yeah, guys, thank you for your questions. Exactly, so chat, exactly. So engine anti-ice is used when visible moisture and less than 10 degrees Celsius. And also the wing anti-ice. The wing anti-ice is used when you have ice. Let me just see how that goes. All right, when you have ice indicating on this probe here. Very simple kind of mechanics. Just a little probe point, a little pointy thing here between the windshields. And when ice accumulates here on this pointer, then you can pretty much, or you then pretty much know that there will be ice on the leading edges of your wings. And so that would be the point to switch on, the latest point to switch on the wing anti-ice. Right, getting back to our programming here. And so the speeds are 147, 148 for V1, 148 for VR, and V2 is 149er. Yes, for example, MCK, in summertime, you can do two things. In summertime, to make sure your passengers don't get unhappy with high temperatures building up when you switch off the air conditioning. So either leave the air conditioning running, or if you need the performance, you can actually use APU bleed for the air conditioning. And that way you still have, you know, the maximum thrust available to the engines. Okay, so flaps also one. And now the question again I get asked very often, how do you actually determine the trim setting? Okay, so with the checklist. So what you would do is you would go into the payload option, and you can see that the takeoff weight is 64.2 today. Actually, you know that from the flight plan. And the takeoff CG is 25.4. So you go on the scale, you go to about 25.4, which is about here. Now, this isn't exact rocket science, okay, guys? It's a rough thing. And so you see here's nose down, and this is nose up. So you can estimate it's about 0.7 nose up. And that's exactly what we are going to put in. Up 0.7. And that's it. And that way we have finished our performance page, and we come to the end. Now, once the secondary flight plan function is inserted, we'll use that and copy the actual flight plan. Right, lots of stuff, right, guys? Okay, so V4 checklist. We have cockpit operations completed. Signs are on auto. Fuel quantity, 5,560 kilograms. Then, altimeters, 1030, 1500 on both sides. And the Windows door is closed. Beacon is on. Thrust levers, idle, and parking brake is presently off. Let's get GSX in here, see if that works. We'll take the Lufthansa. We have to do nose right, tail left. No. So we are preparing the aircraft for the departure. Two things to do here. Max and takeoff config test, and as always I've forgotten to put on the predictive wind shear. Right, cabin is ready, indicating here on the ECAM, or the engine warning display I should say. And the runway is coming up here, so we're going to take the first one on the right. Have you set up your brakes? Yes, I've set them up to the rudder pedals. How much? the EFB, to be honest, it helps. However, if you have already the Navigraph and already purchased that, then I would just use Navigraph, to be honest. I can't really say, you know, it's worth so much more if you have the EFB. For me, I'm just doing this for you guys, for streaming, right? So you could just follow me a lot easier if I'm showing you the chart. And so remember the departure now, all the way to Delta Mike 053, and then we'll turn left. All right, so line up and clear takeoff. Runway 26 left. And we've calculated the PEX off takeoff. And you guys are going to have to remind me once I've set the climb power to switch off the PEX again. All right, let's get on the road, or in the air, I should say. Done our setup, ready, clear takeoff, 50% to stabilize the engines. Sometimes they spool up at different speeds, and so you want to make sure you have symmetrical thrust before applying full power. All right, symmetrical takeoff. Second notch, D10, and so we have Manflex 65, SAS, runway, and outer thrust is blue. If at this point, for some reason, there's something wrong with the modes, then just press toga, put the thrust levels all the way forward. 100 knots. E1, rotate. Positive climb, gear up. Alright, autopilot 1. Yes, you Airbus fan, you would have to wait for the engines to synchronize and have symmetrical thrust. If you go past 50%, then and you have like 20% difference of power because of the different spool up times, you would probably do a 360 on the runway. If it's wet and you know, braking coefficients aren't good. PEX. Yes, I'm on it. Nick, good evening. Nice to see you. So we didn't forget the PEX. Yay. Now we're just waiting for the S speed. Right, S speed, flaps going 0. First restriction, 220 knots. And so now we've passed that point, the FMS will command automatically 250, which is very nice. We're passing transition, setting standard. Standard level 49er. Next restriction, Delta Mike 053 at 70 or above. Should be no problem. Do you pitch down before or after reducing to climb thrust? I would pitch down a little bit. Because sometimes, you know, if you're doing like a really high power takeoff, reduce the climb thrust, that means a lot of thrust is missing. Right, Alt star speed. So we are being cleared level 170. Now, another important thing here, guys. Let me just make that a little bit brighter. Now, we've talked about how we manipulate data either through the MCDU or short-term manipulation through the FCU. So let's, for example, say that now we've been cleared direct to Mercy. So we press direct to Mercy. shows up here, and also you can see it on the nav display, and then you say insert. Now this is like the long-term manipulation, so we're changing the routing, and that's a lot easier to do this via the MCDU. So now let's say ATC says, oh, my bad, heading 235. Now, before trying any programming here in the MCDU, the quickest way is just to pull on the heading selector, set the heading. So for short-term manipulation, this is the way to go. Passing level 100. I'm gonna switch off all the lights. And TCAS is still not active. So now, spoilers are also deactivated. Okay, so let's see. Now we're gonna get a direct to Munich. Now Brandon asks, what about the beam points? Now this is a very neat feature, because if you get a long direct, let's say we get a direct over 200 miles. If you just put in direct to and insert, it'll throw out all the waypoints in between. Now you have to do fuel checks from time to time. And so what you do is you press a beam points and have a look at Mercy and Obudi. What happens now? If I press a beam points, the FMS calculates the 90-degree angle to these waypoints on the routing. And now you have the so-called beam points on the routing, and you have a time and also a fuel estimate for these points. So that way you can you know, do your fuel checks. Oh, you want some coffee, right? So let's switch off the passenger signs. Yeah, Nick, that's the way. That's the way to go. That's what I'm streaming about. Questions, questions, questions. I love it. And I love this aircraft. Beautiful. The Alps, weather is nice. Nick, do you really drink tomato juice on flights? Good question. Why do people order tomato juice? Well, some people say it tastes. So we have Alstar. It tastes a lot better because the thinner air, the air is a lot drier, and so people think that it tastes a lot better. Now I don't know. I can't tell you, but it's like a thing, you know. So when one person starts ordering tomato juice, there's a lot of people saying, oh, that's a good idea. I'm going to have tomato juice as well. And that's just how it is. And now the ATC gives you an out-of-route direct. You mean like it's not on your programmed route. What you do is press direct, and let's say he says direct to... let's see, direct to Herbie. Let's see if you actually have Herbie. Right, so it says direct Herbie. And that's it. That's an off-route direct, and that's how you would do it. And still you can select a beam points again, if it makes sense. I mean, sometimes it doesn't make sense, but that's how you would put in an off-route. What would you turn off? Would you turn off the passenger signs right after 10,000 feet, or wait if there are any turns shortly? Yes, your cabin crew will thank you if they don't get up and pull out the trolleys while you're doing a 30-degree bank. So you pull what, 1.3, 1.4 G in a 30-degree bank, so don't do that, yeah. Also, of course, you would have a look and make sure that you don't have any big clouds around. You know, you're sure there's no turbulence reported before you switch off the seatbelt signs. Definitely. Let me just play around a little bit here with the closest airports. Nice. That's a nice feature. So say you want to, you need to immediately divert because of a fire on board or something, smoke, sick passenger. Then you just press closest airports and have a look. Here's Friedrichshafen. directly below us. Let's have a look. Where's Friedrichshafen? There is Friedrichshafen. There's the Bodensee, Lake Constance, and Friedrichshafen is right here. That is Friedrichshafen. How would you set up a routing to your alternate airport? Okay. Now, first of all, you have to manipulate the destination. You manipulate destination by pressing one of the active waypoints, one of the waypoints in the flight. It doesn't matter which one. You can press Milka, you can press Olben, whatever. That will bring you to this prompt, new destination. So let's say we want to go to Friedrichshafen. New destination. That way, if you now insert that, it'll get to the destination airport as active, and then you can insert the arrival routing in the runway. That's how you would do the diversion. With dual engine failure, can you extend flaps? Well, it's one of the trick questions. It depends if you have windmilling in the engines, i.e. if it's enough windmillings in the engines, then you would have the possibility for the yellow and green engine-driven pump to still supply sufficient power to the hydraulic systems. If the engines are completely damaged, like in the Sullenberger case in the Hudson landing, then if the N2 rotation just goes below, say, like 5%, the pressure will drop, and then you would only have the blue hydraulic, which comes from the RAT, the ram air turbine, the little like propeller that drops out when both AC buses get powerless. So there's a trick that I showed you on one of the videos. If you start the APU, you'll get power back to the system, and then you can use the electric yellow pump, and through the power transfer unit you'll get green hydraulic pressure. So in that case, little trick, start the APU, you will have all three hydraulic systems. Can you please explain all the progress page entries? Okay, so here now at the moment the FMS calculates optimum 315, while the max is 390, because we're gonna have to descend very soon. Here's the descent error, so we got to descend very soon. If you can't start the APU, well, then you just have blue hydraulic power if you're unlucky. So this is what we've actually selected as a cruising level. Now we have 340, which I'm going to put in because I'm going to do a step climb. And the maximum would be 391, while 390 is the maximum we're allowed to do. So 380 would be possible. Depends on the wind which you enter, you know, and so on. All right, so we level at 340. So let's have a look if we can actually do a step climb, step altitudes, and it doesn't work yet. I'm sorry, I can't show you that. It's not implemented. Because you would put in step climb 360 and the FMS would calculate at what point that would make sense. Whatever you put or dial in here, make sure this is indicated correctly on your flight mode and initialization. It doesn't matter if you have any speed here. For example, you select vertical speed, right? And you pull the knob, but you don't pull hard enough. Now you think the aircraft is descending with 1100 feet a minute. Well, have a look at the FMA. Nothing's showing up here because that mode hasn't activated correctly. So make sure that whatever you select here, it is displayed on the FMA. This is master, not this, not the MCDU. This here is the master. Now, for some reason, the weather's getting a lot worse. It's getting foggy now for some reason. Obviously, that doesn't happen in real life that fast, but for our approach today, we're going to simulate that the weather's just turned a lot worse, and so now we're getting the clearance to enter a holding pattern. So we'll do that. We'll enter a holding pattern. I can't show you on the chart. It doesn't have that depicted here. Nope, it doesn't have that. So let's say the next waypoint we're going to have to hold. Press that waypoint, hold, 26 inbound, right turns, insert. Now here's the holding pattern. Insert it. Just about to reach 15,000. And now the aircraft also reduces to minimum holding speed. Very cool feature. So 209 knots, making it a lot more efficient. Alright, so entering holding at this waypoint here. 15,000, well, level 100, that's our descent clearance. So we'll descend in the holding to level 100. Let's see how the Airbus, or the FSLabs Airbus handles this entry. Direct entry now. Only thing that worries me is the high speed. So 250 speed probably calculates this turn with 210 knots or something, but we'll see how that goes. So it's trying with a 30-degree bank. I've read somewhere that some pilots tend to report they are low on fuel in case they are delayed, just to get priority. Oh, that's a bad idea, McFriday. If you report low fuel, some official will come on board and look at your fuel tanks and note them down. And because people have been using that trick, and so whenever you declare low fuel or priority because of fuel, some official will come on board after landing, and then you're in a real heap of trouble if you haven't actually had a fuel problem. Yeah, nice scenery. I love that scenery as well. But however, unfortunately, weather's gotten worse now. Alright, so I've got to hurry up. Alright, so I'm going to exit. I'm just receiving the clearance now. Imminent exit. And so the aircraft, or the immediate exit, so the aircraft will now, even though the holding pattern is still shown here, the aircraft will now continue on the arrival route. And so we'll get the weather for Geneva, have a look how bad it is. Geneva. So presently we have, oh, fog, 200 meters visibility, wind from 010 at 4, 8 degrees, 1026. So it's going to be a fully automatic approach, I'm afraid. Category 3, Bravo. Alright, QNH 1026. The temperature at 8 degrees. So we're going to have to use engine anti-ice in a second. Are we in clouds yet? Yeah, we're coming into clouds, so I'm going to switch on the engine anti-ice. There it is. The wind 010 at 4, 010 at 4. You're back now, Bruno? Okay, welcome. Just set some holding pattern. I'm going to start the approach into Geneva now, and we'll see how the next restriction. Yeah, alright, so the controller says speed up 250 on the speed. That's what we'll do now, 250 on the speed. And so now that we've pressed immediate exit on the FMS, you can also press resume hold again, but we're not going to do that. We're going to fly on the arrival route. So there we go. The holding disappears, and we continue on the arrival route. Did I forget? Oh yes, I forgot to put in the minimum. And so we've inserted the weather. Minimum, no decision height. Since it's a Cat 3 Bravo, fully automatic, no decision height. You can leave the, McFriday, you can leave the exit either by pressing direct to then the next waypoint, or by pressing IMM exit, immediate exit. Yeah. Is the APU on the A320 turned on when doing an outland? No, it's not. No. The electrical system is really redundant on the Airbus, and so you don't have to do that. And also, be aware, if you lose an engine electric generator, you'll get a degrade. So you couldn't do a Cat 3 Bravo approach with a single engine generator. Even if you have an APU generator available in the Airbus, it's not authorized. It doesn't help you. Exactly. Decision height is radio altitude and minimum descent altitude is baro. That is correct. So what does the engine anti-ice do? You see this part here, out of metal, bleed air is taken from the engine, which is hot. Bleed air, because it's compressed, is hot. And it's being put through the front part here of the engine. And so the cowling will heat up. And so ice will not be building up on this part here. Why is that dangerous? If ice builds up and you have a lot of ice and then suddenly it breaks off and is ingested by the engine, it can damage the engine. So in order to avoid that, you heat up the front ring here with bleed air, and that's what the engine anti-ice does. Now we're out of clouds, so we don't need the anti-ice at the moment, so we're going to switch it off. Right, so I'm going to show you for the approach, we are doing the ILS approach. So presently I beamed the field, now we can't see anything anymore because of the fog. And we are going to maintain well 7,000 above, and we have 7.9 as our minimum is here. So we're going to descend to 8,000 feet now. That should be safe. Right, thrust idle open descent. As I said, guys, oops, 80, see? Thrust idle open descent, alt blue and 80. Always read that from the primary flight display, never from here. Right, we've been cleared the approach and we're gonna descend 6,000 feet. I'm gonna press descent and now it'll maintain. So if everything's managed, like I'm doing now with the dots, it's gonna keep the restrictions here. And also you see the D, it's a circle with a D. That's a so-called pseudo waypoint. And at that waypoint, the approach phase will activate automatically. We're gonna just leave that open so you guys can see that. Please, can you place this stream on YouTube? Yes, I will. Well, actually, you can, Davey B, you can. It's saved in Twitch also. So when you go to my Twitch video part, it should be saved there. Yeah, sorry for the electronic flight pack, guys. So the first restriction is 70 at Indis. So the auto flight system will maintain 70 for now. Yeah, well, MCK, you wouldn't ask the cabin crew. What you would do is you would use the pin here. If you have ice there, then you switch on the wing anti-ice. It's as simple as that. No magic involved here, I'm afraid. Good. All right. So, having issues starting number 2 engine. Okay, that is strange. I'm not sure. Without seeing the bleed distribution, I'm not sure what's happening. So the transition altitude is not displayed on the page here. At least I can't see it. But it's 7,000 feet, so we're going to set the altimeter. And that was 1026. Oh, okay, Bruno, I didn't know that. I didn't read that. So the wing is not visible from the cockpit due to performance VAS impact. All right. And just to show you guys, at the moment I have VAS -1, so 1 GB remaining from Munich to Geneva in the FSLabs P3D version. And no Airbus fan, if you don't exit the holding, it'll fly there until the tanks are empty. Yes, wing anti-ice also working with bleed air, yeah, from the engines, like the engine anti-ice. It's taken from a different part. Oh, hang on, we have to. So it's descending now. Setting flaps 1. Press the approach mode. Also approach mode and autopilot 1 and 2. So we have to use both autopilots to get the cut-free dual capability. All right, DVB, yeah, nice. Right, so Lockstar cut-3 single, cut-3 dual. So now we have the, you see the approach phase was activated automatically. I missed that, but that's what happened. I didn't press it manually.
Pull up, terrain. Pull up, don't sink. Too low, terrain. Too low, gear. Too low, flap. Too low, terrain. Glide slope.
Another 20 euros from Brennelt. Man, thank you so much, man. 20 euros out of the fog on a donation update. Thank you, man. Oh my god, you're crazy. So, now we have to continue descent. I'm going to select the gear down to help me descend. I missed the descent point. So open descent, thrust idle, just above the glide slope, but we'll catch that. No problem. Yeah, so we're almost finished with the flight. We're just going to land, taxi to the gate, and then we'll do our next flight on FS Cloud, if you like, Frankfurt, Innsbruck, and I'll be flying the 737 for that. Because I've done enough talking from the A320 today. So flaps coming too. Cut 1, it does its testing, internal testing, and cross-talking and so on. And so once all the tests, the internal tests have been completed, it'll then display Cut 3 dual. One engine taxi departure. No, we'll do 1 engine taxi in. That's what we'll do. MCK. Well, Brennelt is a very generous person. And also, well, I can't exclude any. We've had so many generous donations. I mean, looking at all the names up there, man, I'm really grateful, guys. It just means the world to me. Thank you so much. Now I'm still missing my glide path. Oh my god, let's go down. 777 Innsbruck, I'm not sure if that's a good idea, to be honest. Yep. Thank you. Yeah, it doesn't really affect the capability, but it's better for the co-pilot to see the ILS as well. Yeah. So, almost finished here, guys. Waiting for the 2500 is checked. Switching on the lights. Pull up, yeah. Now we have glide slope star, and I can set the go around altitude. Also very important. 70 is the go around altitude. Make sure you set that either with Alt hold or Alt or with the glide slope active. Eki, I have only installed Orbix Global. I have not installed Vector on the P3D. And like I said, at the moment I'm still running at 3 GB VAS, so I have some VAS left. It is VAS consuming, but they've improved on it. And so it has gotten better. At the moment, I'm not having any problems. I even flew from Frankfurt to Amsterdam and from London to Amsterdam, and it worked. It had about 600 megabyte left. All right, let's concentrate on the approach. 1500 feet. We've done all these settings. Now, just in case something goes wrong, let me just show you that the missed approach, the missed approach just goes straight ahead towards Saint-Pré 7000. So climbing 1800, then track 045 until 9.5 from Geneva, and then proceed to Saint-Pré. So what I've missed to do is set in the Geneva.
1000.
Right, 1000 checked, and let's concentrate on the approach. So, landing checklist, ECA memo, landing, no blue, and the cabin is ready. So everything is good. Fully automatic. About 400 feet radial altimeter. Just below that, you get land. It's a combined mode where glide slope and localizer gets together and has a land here. And so from there on,
500.
if one system fails, the aircraft will continue with the other system. Oh, auto brake, nice.
400.
Good catch, Nick. All right, so auto. Yeah, there you go, land. Yeah, there you go, land.
300.
So full concentration, guys. Have a look at the out of the window here with me. It's very foggy.
200.
No contact yet.
$100.
Still no contact.
50,
There you go.
40.
Runway lights in
30,
sight.
20. 10. Retard.
Thrust levels idle. Spoilers. Reverse green and decel. And we have rollout, meaning the autopilot maintains the runway track according to the localizer. So idle reverse is enough, and right, manual brakes. Now we have to find an exit for us. Oh, here it is. Here it is, and we'll take that exit here. And I can even show you where we are now. And we'll park there. We need some scream function on Twitch. Yeah, no, sorry. So now we heard the APU come online. We have to wait 3 minutes. So what you usually do is start the stopwatch after landing. It's been 2 minutes already, so I'm going to wait 1 more minute, let the engine cool down, and then switch off the engine. If you switch off the engine too soon, if it doesn't cool down properly, it can actually jam. They've had some cases of that happening, so yeah, it's a shaft, the inner drive shaft, or inner connecting shaft from the engine. So, you know, have a cool down period. Otherwise, you could break the engine if you don't do that. Ooh, it's so foggy. My God. I have to admit that this is really cool simulation. Look how the objects come out of the fog here. Very nice. Okay, so 3 minutes have now passed, and 2 things to do. First of all, switch off engine number 2, and then switch on the electric pump, the yellow electric pump, this one here. And you actually hear it now. Nice. And I can hear it better from the cockpit. Yeah, you can hear the high screech, and people hate that. The passengers, they absolutely hate that noise, especially when it's running for a long time. So we'll take this position here. All right, yeah, guys. Next up, the FS Cloud flight. Anybody wants to join? Do that from Frankfurt to Innsbruck, and I'll be taking the 737 out of the hangar. I haven't used that for a while, so I'll do that. Switching off all the lights now, so I'm not blinding anybody. Ooh. Wow. All right, we'll stop here. Setting the parking brake. So the APU is running. We can switch off both engines now. And remember to switch off the yellow hydraulic pump because it'll continue to screech like hell and passengers are going to really be upset. So I'm going to switch off the beacon as well. And transponder is going off. Protective windshield, radar is off. And then we'll read the parking checklist. Oh, hang on. Let's get the passengers off board. Oh, it's actually working. Nice. All right, so the... Yeah, Frozen Malibu, you wished that last time, right? Yeah, so 737. When you said that, I thought I have to do a flight again, yeah. Okay, so the parking checklist, APU bleed, yeah, it's on. And yellow ilic pump, we switched it off. The engines are both off, no fuel flow. And seatbelts are off. And emergency, no, it's parking brake is set. And radar predicted windshield is off. Alright guys, that concludes our flight.